Phases of matter triangle is found in Google Classroom. Please open up Google Classroom and you can click on Phases of Matter Triangle. And then once you click on Phases of Matter Triangle, you can see it like this. And then it looks like a lot of information, and that's a lot. That's overwhelming, possibly. So let's go into slideshow mode. And in slideshow mode, you can follow along with me and do this together with me and fill out your graphic organizer with me as a class. Or you can draw this in your notebook how you see it. But if you do it with me, it makes it a lot easier. So the first box is called title. The title is called Phases of Matter. And this is going to be Phases of Matter Triangle. So find your first box. It's going to be called Phases of Matter. And then you're going to write Phases of Matter in that rectangle right there called Phases of Matter. Did you find it? The Phases of Matter, the first box. Put it in slideshow mode, and you're going to use arrows to click with me, so you can click along. And it is a do together Phases of Matter triangle. So put that on the title. I need to see more pencils writing, please. More pencils writing called Phases of Matter triangle. So Phases of Matter triangle. I need to move the decreased thermal energy and increased thermal energy. Those boxes might be kind of hard to find right now, but you'll see what those boxes are. If you would like to skip those, you can skip those. Phases of Matter. I'm going to move on and follow along with me, and you can click along together. The next box is called a solid. And then in a solid, then we have a liquid is the next box, is our liquid, and then there's a gas. So these are the three phases of matter that we're studying. Scientists have found a lot of other phases of matter, but these are the three that we're studying. These are the three basic ones. There's a fourth one called plasma. That's what happens when you heat up a gas. You can get plasma. It's heating up a gas. There's other phases that you can look up in Google, but we're going to only focus on three. These are the ones that I want you to know about. And all of these phases can change. They can go between a solid, liquid, and gas. They're not changing the molecules. The molecules are staying the same, but something is happening to the molecules to make them change their form. They're going to act differently in different phases. What we're going to start to explore is what's causing their change. What is the change for them? So this is what a solid looks like. Solid, you can draw a little, in that little box right there is some molecules that are locked in position. They're vibrating in place, and they have a high attraction to each other. And that is what a solid is. And so that's something that's just review. You already know that. That's something that you already know. So in your graphic organizer, these are notes for you. You can write down things that you want to remember. You don't have to write down stuff that you already know. You don't need to write down stuff you already know. Just stuff you want to remember. Things that are going to be important to you for you to remember. What would be important for you to remember? If you know that molecules are already locked in position, you don't need to write that. But if you want to remember that they're vibrating in place, write vibrating in place. Or if you want to remember that they have a high attraction, write down high attraction. I think one thing that I would like to include in this really right now is I want to include that these have low energy. That's something that is going to be important to know, that it's going to have low energy. Okay, I want to go back to the slideshow. I just included low energy because some of you were having a hard time on your simulation yesterday, with understanding that a solid was low energy. They are vibrating in place, but they're not moving around like crazy. They're locked in position. The next one's a liquid. We have learned about liquids. Particles slide past each other. They're attracted to each other. They have medium energy. So they're touching, but in random order. Touching, but in random order. They have medium energy. Is a liquid. Please only write down what you want to remember, what you need to know about a liquid. You don't have to write everything. If you already know it, you don't need to write it. But if you need to think you need to remember it, then you would write it down. And the last one that we're going to look at is gases. We haven't done an experiment on a gas yet, but we're going to study it tomorrow. Particles freely move. They have very low attraction. They have high energy. Particles freely move, very low attraction, high energy is what gas particles are. And there's also a little picture to show gas particles with that to help you remember what those are. These are gas particles. So so far, this has all been review. This is stuff you already know. What we're going to add new to this triangle is how these states of matter change. What's causing them to change, and that's what we're going to look at this week. Is we're going to investigate what's causing them to change. What's making them change? In our simulation yesterday, when we went from a solid to a liquid, or we went from a liquid to a gas, the environment changed, and we noticed something. Is we added what's called thermal energy. Thermal energy is also known as heat. I think I'm going to add that in really quick. Increase thermal. Thermal means heat. So heat energy. And that's what that box represents, is that we have increased the thermal energy. So all of the red arrows are showing that it is increasing thermal energy. You get heat. You're going to add heat energy to it. And when you add heat, that is going to make the molecules more excited. It's going to give them more energy, and they're going to move around more. Increasing their thermal energy, they're going to get excited, and they're going to move around more. So we're going to increase the thermal energy. This phase change from a solid to a liquid is called melting. It is endothermic. It is called melting. It is called endothermic. Endo means energy in something. Endo is going to be energy in something. We're going to be talking about endothermic a lot over the next 2 months. Endothermic energy is being given or being added. It's inside. It's being endo is energy in, and melting is the phase change. If you'd like to circle the word melting, you can. Melting is called this phase change. Whenever a solid melts to a liquid right now. Mauna Loa is having this taking place right now, where rock has been melted inside the Earth's core. The magma is liquid rock, and that's spewing out as lava in Mauna Loa right now. Mauna Loa has lava flows of melted rock, solid to liquid, endothermic. Now, you can go backwards as well. Liquid to a solid. A liquid to a solid can change, and that's where this is called decrease thermal energy. You can decrease thermal energy when you take away the energy. You remove energy. You're going to remove energy, decrease the thermal energy, and that will change a liquid to a solid. What is that called? Going from a liquid to a solid. That is called freezing. Freezing is what it's called. So freezing is exothermic. It's exothermic because exo means heat being removed, heat exiting, exiting heat. Exo, exit, thermic, heat, exit, heat. Exothermic. Remove heat, heat exits. Energy, it's energy being removed, energy being exited. So all a freezer is just an energy removal system. A freezer is energy removal system. Taking away energy from the system, it's energy removal system. So freezing is exothermic. So solid to liquid is called melting. Liquid to solid is called freezing. Okay, make sense? The rest of it is, let's go on. The rest of it is going to be this. We're going to continue. Now we're going to go liquid to gas. So you want to change a liquid to a gas, you add energy. Add energy. There's our energy line right there. And this is called vaporization. That's the word vaporization. Vaporization is vapor, water vapor, liquid to gas, vaporization. That is endothermic. Heat has to enter it. So if you put liquid, if you add heat to a liquid, you're going to get gas. So the arrow is showing that you're going to add that to it. Add heat to it, and you're going to get a gas. Liquid to gas, endothermic. How's my speed? Am I going too fast or too slow? Good, McKenna. Thank you for the feedback. Al, quick, just one. If you're going to go from a gas to a liquid, you have to take out energy, and we're going to have the blue arrow go backwards, and that's going to be called condensation. Condensation is when gas will come back to a liquid. Gas will turn back into a liquid. Gas turns back into a liquid. Gas turns back into a liquid. This is a really important one that I'd like you to understand. So in your simulation, if you can make sure that you do the gas to liquid one, it's really, really cool to be able to see that. And this happens all the time. Gas to liquid. You're probably seeing this right now. Raise your hand if this morning you drove in a car and the inside of the windows all fogged up once you got into the car. Guess what that was? That was a gas to a liquid. It was the water vapor in the car was condensing on the windows. Condensing on the windows. I'm not going to tell you why though. That's science. That's something you're going to have to figure out. We're going to do some experiments with that, but that's something to think about. Why does that happen? Why does condensation? Why does a gas turn into a liquid? What's actually happening with the science there? So I'm going to let you think about that. I don't want any answers. I don't want any answers right now. I want you to think about that because we're going to do some experiments on it. Gas to a liquid. Condensation, that's exothermic. You're going to remove energy from a gas. Gas is super high energy. You're going to take away its energy, and it's going to become medium energy. It's going to become medium energy. Next step is a solid can become gas immediately. A solid can skip over a liquid. A solid doesn't have to become a liquid. A solid can jump right to a gas. And if you're going to add tons of energy to, let's say you're going to add tons of energy to a solid, lots and lots of energy all at once, then that gas is going to be called, that process is called sublimation. Sublimation, and that's endothermic, because you're going to be anytime you add heat, you have to add energy. It's endo. You're going to be adding something, endo. If you're going to be removing something, it's going to be exo. Heat is exiting, and this is going to be called exo. So the exo word is deposition. Deposition, that's when a gas becomes a solid. And I don't have the tools to make this happen in the classroom. I can't take water vapor in our classroom air immediately and turn that into a solid. I can't immediately have the water vapor and air make ice crystals. I don't have the tools. If you go up into the Sierra Nevada range right now, this is happening in different places where water vapor will all of a sudden have all the energy removed. It gets so cold that it'll turn to a solid, and there'll be ice crystals in the air that begin to drop, where they form ice crystals immediately on the trees. Deposition. And the last box is up in the top, and it is called endo, heat enters, exo, heat exits. So that's our last box of writing there. This is the phases of matter triangle. These are the different phases they can be that you are going to be looking at. You've already seen some in the classroom already. You're going to be looking at some more of these over the next couple of days in your lab. You don't have to get the door. That door's not locked. So you're free to click through these as much as you want. You can feel free to click through these so that you can go back. Go ahead and click through these as much as you want.